welcome to the deep dive.
Thanks for having me.
Today we're gonna dive into the world of marine boilers
Okay.
and all the steam machinery that they power. We've got a whole stack of sources here. We've got introductory lectures. We've got some really in-depth maintenance manuals. Really, everything we need to get a solid understanding of how these massive systems work.
All right.
And our mission for this deep dive is to distill, the essential knowledge of how steam is generated on ships.
Okay.
And how it's used and really what keeps these systems running safely and efficiently.
Right.
So we'll be talking about different designs of boilers, the safety systems that are bolted on them, the valves and gauges,
Right.
how combustion works, the process of water treatment, the control systems, turbines, and operational procedures.
Okay. That's good.
So let's jump right into it. Let's get started with kind of the heart of the system,
Yeah.
the boiler itself.
Right.
What is a boiler doing?
A boiler's job is to add a lot of energy or enthalpy to water to create steam.
Okay.
So you heat the water up beyond its saturation point.
Right.
And the steam that you generate is high pressure steam. There's different enthalpies that you have to deal with. You have the enthalpy of the heated water itself.
Okay.
Then you have the additional enthalpy that's required for that water to completely change into steam.
Okay.
And then finally, you have the total enthalpy of the steam.
Okay. So you're adding enthalpy to the water and then additional enthalpy on top of that to get the total enthalpy of that steam that you've created.
Yeah, exactly.
Okay, and the steam that we're talking about, is this not just the the steam that comes out of a tea kettle? I remember reading about wet steam.
Yeah, so the steam that's produced in a marine boiler,
Okay.
it's not the pure steam that you think of. It always contains a small amount of water,
Okay.
typically around 5% by mass.
Okay.
And we refer to this as its dryness fraction.
Okay, so it's not completely dry. It's 95% dry.
It's exactly.
Okay. Now let's talk about the different types of boilers that we've seen in our materials.
Okay, so from what we've read, there are different types of boilers. We have the smoke tube boilers. We have water tube boilers.
Okay.
And then we have composite boilers.
Okay, so 3 different types: smoke tube, water tube, and composite.
Exactly.
Okay. Let's start with smoke tube. What are these boilers?
So smoke tube boilers, you'll have hot gas passing through tubes
Okay.
that are surrounded by water.
Okay.
And examples of these types of boilers are the Scotch boiler, the Cochrane boiler, and the Aalborg Mission OC boiler.
Okay, so the hot gas goes through the tubes and the water surrounds those tubes.
Yeah.
Okay. And what are these typically used for?
So smoke tube boilers, they're typically used for smaller quantities of low-quality steam.
Okay.
You'll see them used for things like cargo heating in port or fuel tank heating.
Okay, so for heating rather than propulsion.
Yeah. For the most part, yeah.
Okay.
Now, one advantage of the smoke tube boilers is that they are not as demanding on the quality of the feed water that's put into them.
Okay. So the feed water quality is not as important in these types.
Yeah.
All right. Are there drawbacks to these smoke tube boilers?
Yeah, so one drawback of smoke tube boilers is that if a tube fails,
Right.
you could have a large release of steam and water.
And that's obviously bad.
Yeah.
Because you've got extremely high pressure steam and water.
Exactly. And this can be dangerous if it's released into the machinery space.
Right. And also, I would imagine if you lose a tube, you're going to lose a lot of your steam generating capacity.
Right.
So you're not going to be able to produce as much steam.
Exactly. Another limitation of smoke tube boilers is that the rate at which you can produce steam is kind of limited by the natural circulation of the water.
So there's only so much steam you can produce in a given amount of time.
Exactly. Yeah, exactly.
Okay. Now let's move on to the second type that we mentioned, the water tube boilers.
Right.
What are the defining features of these boilers?
So in water tube boilers, the water actually flows through the tubes.
Okay, so it's the opposite of the smoke tube boiler.
Yeah. And the hot gas surrounds these tubes.
Okay.
And they're typically used when you need larger quantities of steam.
Okay.
For instance, for things like cargo pumps or even main propulsion in some cases.
Okay, so these are more heavy duties.
Yeah.
These are the workhorses of the steam world.
Exactly.
Okay. Now let's talk about the Aalborg Mission OC boiler.
All right.
That was a specific type of boiler that was mentioned quite frequently.
Yeah, so the Aalborg Mission OC boiler is kind of a combination of a water tube and a smoke tube boiler.
Okay. Interesting.
Yeah, and it's a vertical boiler that has these integrated pin tube elements.
Okay, pin tube elements.
Yeah.
What are those?
So these pin tube elements, they're tubes with pins welded on them to increase the surface area.
Okay, so these pins stick out, and that increases the surface area of those tubes.
Yeah.
Okay. And why is that important?
Well, this increased surface area, it allows for better heat transfer.
Okay, so it allows you to make steam quicker or more efficiently.
Yeah.
Yeah.
More efficiently. And it's also important because it makes the boiler more compact.
Okay.
Yeah, so the Alberg Mission OC boiler, it's also pre-assembled and it has its own control panel.
Okay, so it comes as kind of a self-contained unit.
Yeah, yeah. It's kind of a plug-and-play system.
Interesting. And what types of burners are used in these?
So they can use pressure jet burners or rotary cut burners.
Okay.
They have an output of about 3.5 megawatts and can produce about 0.75 to 5 tons of steam per hour on oil.
Okay, so it's a pretty significant steam generating capacity.
Yeah.
Now, we also mentioned composite boilers. What are those?
So composite boilers, they're boilers that combine a waste heat recovery section
Okay.
with an oil-fired section.
Okay, so it can take the waste heat and use that to generate some of the steam.
Yeah. And this makes them very versatile and fuel efficient.
Okay, so a little bit more complicated
Right.
system, but obviously very good for fuel efficiency and minimizing our impact.
Right.
All right, so we've discussed the different types of boilers. Now let's talk about some of the other essential pieces of equipment that are attached to a boiler.
Okay.
We'll start with I guess what's going to be the most important, the safety valve.
Right.
What is the purpose of a safety valve?
So safety valves, they are essential to prevent a boiler from,
Okay.
catastrophic failure
Okay.
due to overpressure.
Okay.
Basically, if the pressure inside the boiler gets too high,
Okay.
the safety valve will release steam.
So it's a pressure relief valve.
Yeah.
Okay, and it's the only thing preventing the boiler from exploding.
Exactly. It's the only thing.
Okay.
Now, these safety valves, they're designed to pop open.
Pop open. What's the reason for that?
So this popping action, it ensures that the valve will fully open even if the pressure increase above the set point is small.
So it's got to open quickly and it's got to open completely.
Yeah.
Okay. And how is that achieved? How is this popping action achieved?
So the way it works is the valve disc. It has this shroud or skirt around it
Okay.
that forms what's called a huddling chamber.
A huddling chamber.
Yeah.
Okay.
So when the valve starts to lift
Okay.
and the high-pressure steam enters this huddling chamber,
Right.
it acts on a larger surface area,
Okay.
which increases the upward force on the valve.
Okay, so it's basically like a force multiplier in a way.
Exactly. And this increased force, it overcomes the spring force that's holding the valve closed.
Okay.
And that causes it to pop open. This huddling chamber, it's also shaped in such a way that it reverses the flow of steam coming out,
Okay.
which creates a reaction force that further helps to lift the valve.
Wow, so it's using the pressure of that escaping steam to actually enhance the opening of the valve.
Exactly. And then you have the expansion of the steam, which also contributes to this rapid opening.
Okay.
Because the steam, it goes from a high pressure to a low pressure environment.
Right. And that rapid expansion helps to force the valve open even more quickly.
Yeah.
So once you've set the valve pressure, the pressure at which it should open,
Right.
there's a procedure to basically lock it in place.
Yeah, so you basically want to secure it so that it doesn't accidentally change.
Right.
So you would remove any temporary locking devices that were used during the setting process.
Okay.
You tighten the cap screws and the bolts,
Okay.
and you would mount the lifting lever, which allows you to manually test the valve.
Okay.
And then typically you'd put a lead seal on it.
A lead seal on it.
Yeah.
What's that for?
This is to show that the valve hasn't been tampered with.
Oh, okay.
Yeah.
It's like a tamper evidence seal.
Yeah.
Very interesting. Now, there's also a specific test that's done to make sure that the safety valves can do its job.
Yeah, so there's this test called the accumulation of pressure test.
Accumulation of pressure
Yeah.
test. Okay,
Yeah.
what is that?
So this test is done with the boiler isolated.
Okay.
And it's basically to see if the safety valve can handle the maximum steam output of the boiler.
Oh, so it's like a full load test.
Yeah. You're checking to see if the pressure stays within a safe limit.
Okay, that makes sense. Now let's move on to steam and feed valves.
Right.
What are these two different types of valves?
So steam valves, they regulate the flow of steam out of the boiler.
Out of the boiler.
And feed valves, they regulate the supply of feed water into the boiler.
Okay, so one is for letting the steam out to do its work. The other one is for replenishing the water.
Exactly.
Okay.
Yeah.
And our sources really emphasize that all the connections on the boiler,
Right.
whether it's a steam outlet or feed water inlet, must have stop valves fitted directly on the boiler shell itself.
Yeah, yeah, and they should have minimal distance pieces between the boiler and the stop valve,
Okay.
to reduce the chance of leaks.
Okay, so you want to make sure that that connection is as short and as strong as possible.
Yeah, yeah. And it's also worth noting that most stop valves, they close against the boiler pressure.
Okay.
With the exception of feed water connections, which may close against the feed pressure.
Okay.
And for screw down valves, the standard is to close them clockwise.
Clockwise, okay.
Yeah.
We also talked about some specific types of these steam valves.
Right.
We have steam stop valves and boiler stop valves. What's the difference between those?
So steam stop valves, they're used to isolate steam-operated equipment.
Okay.
And for the larger ones, they usually have a bypass valve to warm up the system before you open the main valve.
Okay.
And then you have boiler stop valves,
Okay.
which isolate the whole boiler from the steam system.
So if you need to take the boiler offline.
Yeah. And these are generally angle pattern globe valves that are screw down type.
Okay.
And some of them will actually have automatic closing mechanisms
Okay.
for emergency situations.
Okay, so if something happens, it automatically shuts off the steam to the system.
Exactly. And for systems where you have two boilers supplying a common steam line,
Okay.
you have to have screw down non-return valves.
So you're preventing steam from going from one boiler to the other.
Exactly.
That makes sense. Now, how does that feed water actually get back into the boiler?
So the feed water, it has to enter the boiler in such a way that it doesn't hit hot surfaces
Okay.
because that can cause damage.
Rock thermal shock.
Yeah. So it's often fed through the steam drum.
Okay.
And we also saw this really interesting example of a pneumatic controlled feed control valve system.
Okay.
So it's a system that uses a differential pressure water level transmitter to monitor the water level.
Okay, so it's always monitoring how much water is in the boiler.
Yeah. And it works by measuring the difference in pressure between two legs, a reference leg and a variable leg.
Okay.
This pressure difference is then converted into a 4 to 20 milliamp signal.
A 4 to 20 milliamp signal.
Yeah.
Okay.
Which is used by the control system.
Okay.
To adjust the feed water control valve and also to give a remote indication of the water level.
Okay, so there's a signal being sent from the boiler to the control room that says this is how much water is in the boiler.
Exactly.
So now that we've talked about, getting that feed water back into the boiler,
Right.
let's talk about water level indicating gauges.
Okay.
What is the purpose of these gauges?
So water level indicating gauges, they are essential for maintaining the correct water level inside the boiler.
Okay. Why is that so important?
Well, if the water level is too low,
Okay.
the boiler can overheat and be damaged.
Right.
And if the water level is too high, you can get carryover.
Carryover.
Yeah.
What does that mean?
Carryover is when water droplets get entrained in the steam.
Okay.
And this can damage equipment like turbines.
Right. So you want that steam to be as dry as possible.
Exactly. And these horizontal shell boilers, they have an interesting characteristic.
Okay.
When the load on the boiler increases, the water level can actually rise.
The water level can rise.
Yeah.
But you're actually using more water to make more steam.
You are. But the volume occupied by the steam water mixture, it actually increases.
Okay.
And as the water level rises above the center line of the boiler, the steam release area, it actually decreases.
So you're making more steam, but there's less area for that steam to escape.
Yeah. And this can lead to more carryover.
Okay, so it's almost like a counterintuitive thing where the water level is going up, but it's actually a more dangerous situation.
Exactly. So the Boilermakers, they take all of this into account when they're designing a boiler.
Yeah, okay.
They specify what the normal water level should be, and they also specify the height of the steam octake.
So they're very carefully engineering the design of the boiler to prevent this dangerous carryover situation.
Right.
Okay, now let's talk about the types of these water level gauges.
Okay.
We have the tubular gauges and the flat or plate type.
Yeah. Yeah. So tubular gauge glasses, they're pretty simple.
Okay.
They're used for low to medium pressure boilers.
Okay.
And they have this glass tube that allows you to see the water level.
Right.
Now, flat or plate type gauge glasses, they're used for higher pressure.
Higher pressures.
Yeah. Above 35 bar.
Okay.
And they have this mica sheet between the glass and the boiler water to protect the glass from corrosion.
So they're more robust, these flat type gauges.
Yeah. Yeah. A typical gauge glass assembly will have nuts, box heads, tubes, screws, cocks, drain cocks, and a gauge body.
Okay. And we talked about blowing through the gauge glass.
Yeah.
What's the purpose of that?
So blowing through the gauge glass, it's a procedure that you do to make sure that the gauge glass and the connecting passageways are clear.
Clear. Okay.
Yeah. You want to make sure that there's no blockage.
Right. Because if there's a blockage, the reading's going to be wrong.
Exactly. You typically do this before you start up the boiler.
Okay.
Before you shut it down.
Okay.
And also as part of your regular maintenance schedule.
Okay. And how is it done? What's the procedure for blowing through?
So you carefully open and close the drain cock and the isolating cocks.
Okay.
To allow water and steam to flow through the glass.
Okay. So you're basically flushing it out.
Yeah.
Making sure there's a clear path.
Exactly.
Wow.
Exactly.
Okay.
And the gauge cocks themselves, they need to be maintained as well.
Okay.
They have packing that can wear out.
Right.
So you have to tighten the packing nuts periodically.
Okay.
And sometimes you have to dismantle them to replace the packing.
Right. So it's just like any other valve.
Mm-hmm.
Got to make sure the seals are good and there's no leaks.
Exactly.
Now let's move on to the fiery heart of the boiler system. Let's talk about combustion.
Right.
What are the essential factors that have to be correct to make
Okay.
sure that you're burning efficiently and safely?
All right. So for successful combustion, you need three things. You need air, fuel, and furnace volume.
Okay.
The air supply, it has to be properly managed.
Okay.
The fuel has to be prepared properly.
Okay.
And the furnace volume has to be large enough.
Large enough.
Yeah.
Why is that important?
Well, the furnace volume, it allows for the complete combustion of the fuel
Okay.
before the hot gases hit the tubes.
Okay. So you need to give it enough time to completely burn before it hits those cooler surfaces.
Exactly. So let's talk about the air supply.
Okay.
The air register, it divides the combustion air into a primary and secondary airstream.
Okay. So two different airstreams.
Yeah. And the air register also directs this air for mixing and regulates the air supply to each burner. The fuel also has to be properly prepared.
Okay.
The fuel oil, it has to be atomized.
Atomized.
Yeah.
What does that mean?
So you break up the fuel oil into tiny droplets.
Okay.
This increases the surface area of the fuel, which makes it burn better.
So the smaller the droplets, the better the combustion.
Exactly.
Now, we also came across the concept of excess air.
Right.
What does that refer to?
So excess air is the amount of air that's supplied to the burner,
Okay.
in addition to the minimum amount of air required for complete combustion.
Okay, so you're adding a little bit of extra air.
Yeah. And this excess air, it reduces the CO2 content in the flue gas,
Okay.
but it also reduces the efficiency of the boiler.
Okay, so it's kind of a balancing act.
Yeah. So you want to have just enough excess air
Okay.
to ensure complete combustion.
But not too much excess air so that you're wasting energy.
Right. A good combustion index, it has high CO2 content in the flue gas.
Okay.
And no smoke.
Okay, so it's got to be burning clean.
Yeah.
Now, let's go back to this idea of the air register.
Okay.
What does that actually look like? How does that work?
So the air register, it's an assembly of vanes and plates.
Okay.
And they're located around the fuel oil burner.
Okay.
And what the air register does is it divides the air into primary and secondary streams.
Right, we talked about that.
Yeah.
Yeah.
And it also directs the flow of air
Okay.
for proper mixing with the fuel. For wide range burners.
Okay.
The air register, it can be pneumatically operated.
Okay, so it's controlled by air pressure.
Exactly.
Yeah.
The primary air, it helps to stabilize the initial flame front.
Okay.
And the secondary air, it ensures complete combustion.
Okay.
And the secondary air, it also has these swirler vanes.
Swirler vanes, okay.
Yeah.
What are those doing?
So the swirler vanes, they impart a spin to the secondary air,
Okay.
which helps it mix better with the fuel.
Okay, so it's creating like a vortex.
Yeah. Yeah.
Okay.
And this improves the combustion process.
So it's all about mixing the air and the fuel in the most efficient way.
Exactly. Exactly. And the swirling action, it also helps to stabilize the flame.
Okay, so it helps to keep that flame burning where it should be burning.
Yeah.
Yeah.
The secondary flame, it's really important for generating heat,
Okay.
and you need enough time
Okay.
for this combustion to take place
Okay.
before the hot gases, they hit the boiler tubes.
Okay, so you want to make sure that combustion's complete
Yeah, yeah.
before the gases go on to do their work.
Exactly, exactly.
All right. Now let's move on from the combustion side of things
Okay.
and talk a little bit about the thermodynamics of steam generation. We talked about enthalpy earlier.
Right.
Um, how exactly is that heat energy causing that water to change into steam?
So steam is formed by adding enthalpy to water.
Okay.
You add enough enthalpy to reach the saturation point,
Right.
which is the temperature at which water boils.
Okay, so it's 100 degrees Celsius at atmospheric pressure.
Yeah, yeah. But the saturation temperature, it changes with pressure.
Okay,
Yeah.
so if you're at a higher pressure, it's going to boil at a higher temperature.
Exactly.
Okay, okay. Now, we talked about a couple of different types of enthalpy. There's the enthalpy of saturated water,
Right.
denoted as HF,
Yeah.
and the enthalpy of evaporation,
Right.
which is HFG.
Yeah. Yeah. So HF, it's the energy that's stored in water at its boiling point.
Okay.
And HFG, it's the additional energy that's needed to turn that water into steam.
Okay.
And these enthalpy values, they change with pressure.
They change with pressure.
Yeah.
Okay, so how do they change?
So as pressure increases, HF increases.
Okay.
And HFG decreases.
Okay, so HF is the enthalpy of the saturated water.
Right.
If the pressure's going up, that means that the boiling point's going up.
Yeah. Yeah.
So you need more energy to get it to that higher temperature.
Right. Right. And HFG decreases because at higher pressures,
Okay.
the molecules, they're already closer together.
Okay.
So you need less energy to break them apart.
Yeah.
And form steam. Now, HFG, it's used for two main things.
Okay.
It's used to overcome the intermolecular forces in water,
Okay.
and it's also used to do the work of expansion when water turns into steam.
Okay, so you need energy to break those molecules apart.
Yeah.
And then additional energy to allow them to expand into that gas.
Exactly. Exactly. And HFG is also dependent on temperature. So
Okay.
at 0 degrees Celsius, HFG is about 2,500 kilojoules per kilogram.
Okay.
But as temperature increases,
Okay.
HFG, it decreases.
Okay, and it actually reaches 0 at the critical point.
Exactly, which is about 374 degrees Celsius
Okay.
and 221 bar.
Okay, and beyond the critical point, there's no distinct phase change between the liquid and gas.
Right. Right. So the steam that you get from a boiler, it's called saturated steam
Okay.
because it's in contact with water.
Right.
And it can't get any hotter than the boiling point of that water.
Okay.
To get hotter steam, you need a superheater,
Okay.
which heats the steam up even more.
So it takes that saturated steam from the boiler and heats it even further.
Yeah. Yeah. And the superheated steam, it's great for turbines
Okay.
because it prevents condensation inside the turbine.
Okay, so that prevents damage to the turbine blades.
Exactly. But for heating applications, sometimes you need to de-superheat the steam.
De-superheat it.
Yeah.
So cool it back down closer to its saturation point.
Yeah. Yeah. For things like heating coils,
Right.
you want the steam to condense,
Right.
to release its latent heat.
Okay.
And there are two main ways to de-superheat steam.
Okay.
You have temperators.
The temperators, okay.
Yeah.
And what's the other one?
And spray-type de-superheater.
Spray type.
Yeah.
Okay. What are temperators?
So temperators, they're basically heat exchangers
Okay.
that transfer some of the superheated steam's heat
Okay.
back to the boiler water.
Okay.
And spray-type de-superheaters, they inject feed water into the steam flow.
So it uses the evaporation of the water to cool down the steam.
Exactly.
Okay. Now, we've talked about, getting that water into the boiler and how it's turned into steam,
Mm-hmm.
but we can't just use any water in these boilers, right?
Right.
We have to treat it.